Welcome to my new video about the true-hole soldering machine that is made using a modified 3D printer. I already made one version of this 3D printer, and this is what you are watching in the video right now. The video is speed up like 20 times, so it's not real time, but just to show that indeed it is working. The reliability is quite good, even if it's not 100% perfect. So I got an idea how to modify it. Actually, I don't want that the stepper model of the extruder, which is quite heavy, that pushes over the iron tip directly. So I thought, why not to make some new videos where I show how to dismount and mount it and show the new structure so that if you are interested you can see the whole process, how I made it, and also the software and the calibration. Here the job is finished, and this is the result. As you can see, the previous model was quite good, but now let's see the new support that I'm going to use. The lower part is can move freely for some extent, and the extruded model will be mounted directly on the 3D printer structure. The 3D printer that I used is the longer and was the cheapest model at the time I bought it. I see now the price are very high compared to previous. This one I buy for 175 euro. As you can see, I modified also the bed of the printer. I attached an iron grid and I printed the templates that are used to position the two all components so they can stay in the proper place. I will show later how I made these templates. And now let's start dismounting the frame. First of all, I detached the extruder and the motor. The motor is on the back, it's not visible now. It's a NEMA 17 motor. I made some modification, and you can see the spring is way softer than the original. And also I made some modification to the wheel that push the solder wire. I changed the Teflon tube here in orange. Now the inner diameter is 1 millimeter, which can accommodate the solder wire of 0.5 millimeter. The previous one was 1.9 millimeter. Now let's dismantle the other parts. You can see that the tip of the iron has some degree of movement compared to the structure of the 3D printer. This is made by intention. I try to use all M3 type bolt and nuts for this support, but I also use them for to keep the tip of the iron in place. So now I'm detaching the sensor for the temperature. That sensor is not really used in the G code, but just for me to check the temperature of the structure. The iron tip switch on and off coming from the command of the fan. So when the 3D printer switch on the fan, indeed it switch on the iron tip heater. That was the part that was attached to the 3D printer. Time to detach the iron. This is a quite inexpensive item, and it has its own temperature control. So the 3D printer just need to switch on and off. It's very important that the iron tip is very firmly attached to the structure, and this is the reason why I put several pieces to, yeah, for example, like that I'm showing, the structure is made of iron. And now let's take the new support, see if it fits. There are three holes where the bolt can be put to attach it to the 3D printer. You see that movement? Yeah, that is the part where the iron will be attached. Now let's proceed with mounting the iron. Now I'm mounting the attachment on the plastic of the iron tip. As you can see, there are quite a number of nuts and bolts to attaching the plastic part. And here is the result. Attaching the hot end of the iron is a little more complicated because I had to use some metal part that then attach to the plastic and should avoid the transfer. For this purpose I use M4 bolts that are 5 centimeter long, and I use also a silicone tube to isolate thermally the bolt and the plastic. Actually, the temperature on the bolts is not so high. It, I measured that to reach around 60 degrees. So let me show you. I unscrew the nut, then there is a washer, and then there is the silicone tube. The dimensions of the silicone tube are 8 millimeter the outer diameter and 4 millimeter the inner diameter. That fit perfectly with the M4 bolts. Now let's put everything together and mount it on the frame. It takes a little time, but it's not so complicated. Now let's mount the part that is supporting the needle. Later you will see how the soldering wire will pass through the needle. The needle position can be rotated and move up and down, so it's possible to have very fine adjustment of the position and the orientation of the needle. So in this way the solder wire will touch the iron exactly in the right place, which is very important. Here I'm mounting the counterweight because as you can see the iron tip pushing on one side and I need to balance it. This is not my final design. Uh, I modified it later, but the same principle but shorter and more compact. Now everything is at level. And you can see it move for some degree. Now it's time to mount the extruder module. There are four bolts. There is also the lever attached to the spring. This will keep the solder wire in place and provide the right tension. Now it's time to attach the support for the needle. This part is also 3D printed. You can see it can rotate. Next, I'm putting the solder wire inside the mechanism to push it and through the tube and finally inside the needle. The solder wire is very thin. It's around 0.5 millimeter, so this operation is a little delicate. Need some patience. Anyway, this operation is done only once and will be done again when I replace the solder wire. Okay, now it passed through the needle. The needle is very easy to find. You can look for dispensing needles, and this has a length of 5 centimeter, and it is gauge 18, which is equivalent to in diameter 0.84 centimeter. So it's a little bigger than the wire, which is 0.5 millimeter. The mounting is now complete. In the next video, I will show how I made the templates and then some calibration and the software. Thank you for watching.